Hi students, this is Miss Johnson with 6-1 Graphing Systems of Equations. Our SPBAT for today is we are going to determine the number of solutions a set of equations has, and we're going to solve them by graphing. Alright, well, how are we going to know how many solutions two equations will have? Well, there's all sorts of different ways to look at it. When we have graphs, two equations are either going to graph and they are going to cross. Two equations are going to graph and there's actually two lines here. They're going to line up right on top of one another. Or two graphs are going to be parallel and will never cross. So as we are taking a look, when graphs cross at exactly one place, then they have one solution. And that solution is right here where they cross. When graphs end up to be graphed exactly the same, these two lines, there are an infinite number of solutions. It can be here, it can be here, it could be here, and I could keep going. When two lines are parallel, they will never cross, they will never intersect, therefore there are zero solutions. There is some terminology that mathematicians use to describe these. If there are graphs that cross and have one solution, we call that consistent and independent. And when graphs have infinite number of solutions, we call that consistent and dependent. So when they have a solution, it's consistent, and depending upon how many solutions they have is independent and dependent. When graphs do not cross, when they do not have a solution, they are called inconsistent. And when you're looking at the equations, there's some easy ways to look and figure out how many solutions you have. If the two equations have different slopes, you know that they are going to cross. If two equations have the same m values and the same b values, meaning they have the same slope and the same y-intercept, you know they're going to be consistent and independent with an infinite number of solutions, graphing right on top of one another. And if the equations have the same m, the same slope, but different b, different y-intercepts, then that's when graphs are going to be parallel, so they are not going to have any solutions and be inconsistent. Couple other vocabulary words. Consistent. Consistent is when there is a solution, and inconsistent is when there is not a solution. When you have a solution, dependent has many solutions. It depends where you look at the graph to get the solution. Independent happens when there is just one solution. Alright, let's put this terminology into practice. Example number 1. What terminology can be used to describe the red and green lines? Well, here is the red line, and here is the green line. And these two lines, red and green, are parallel, and when they are parallel, they will not cross, therefore there's no solution, and we call that inconsistent. Alright, let's take a look. What terminology can be used to describe the purple and red lines? Purple is right here, red is right here. They cross at exactly this one point. So when they cross at this one point, they have one solution, and we call that consistent and independent. Consistent because it has a solution, and independent because it is one solution. Alright, let's work with some equations now. So we have a system of equations, and a system is just a fancy word for having two equations. Alright, the directions say we're going to graph the system of equations below, and we're going to determine how many solutions it has. And if it has one solution, we are going to name it. Alright, so we have x minus y equals 2, and 3y plus 2x equals 9. In order to graph these, we need to put these into slope-intercept form. We need them to look like y equals mx plus b. Well, this equation on the left is pretty close to being set. The y is on the left-hand side, but we need to get the x on the other side. So we'll subtract x from both sides. So now we'll have negative y, don't forget that negative in front, negative y equals negative x plus 2. And we don't want negative y, we want positive y, so we're going to divide both sides by negative 1. So we've got y equals x minus 2. We will now be able to graph this. The other equation, 3y plus 2x equals 9. Again, we need to get the x to the other side, so we'll subtract 2x from both sides. So 3y equals negative 2x plus 9. The y needs to be y itself, so divide everything by 3. So y equals negative 2 divided by 3. We'll just leave that as our fraction of negative 2/3 x. And then we also need to divide 9 by 3 to get 3. All right, now that we have both of them, we are now ready to graph. And the first equation, y equals x minus 2, you want to start with your y-intercept, which is negative 2. So I'll go down to my y-intercept and I'll put a dot at negative 2. And my slope is just x, so remember our slope is 1. So we go over 1, up 1, over 1, up 1, and we now have our line. All right, let's go to the other equation. Y equals negative 2/3 x plus 3. So we're going to start again with our y-intercept of plus 3. So I'm going to go to the y-axis. I'm going to go up 1, 2, 3, put my dot. And now our slope is negative 2/3. Remember, it's rise over run, so I'm going to rise negative 2. So really I'm going to go down 2, and I'm going to run 3. So I'm going to go down 2 and run 1, 2, 3, and it's right there. Down 2, run 1, 2, 3, and now we have our second line. And as we can tell, these two graphs, when they have been graphed, they do intersect. They cross right here, so it has a solution, and that solution is over 1, 2, 3. It's up 1. So that has a solution, and it wants us to name it, so we will name it as a coordinate pair. So we'll use our parentheses, and we'll have 3, 1 as our coordinate pair. Using our terminology, we would say that this system is consistent because it has a solution, and it's independent because it has one solution. All right, let's go ahead and get to our summary. You can do your summary right now on your notes. You can do it on your summary sheet, or you can make a foldable study guide. Thanks for tuning in. This is Solving Systems of Equations by Graphing.